introduction to descriptive statistics. Statistics plays a fundamental role in understanding and analyzing data. In this course, we will learn the basic concepts of and techniques used to summarize, organize, and interpret data effectively. By the end of this course, you will be able to describe datasets, compute important statistical measures, and draw meaningful conclusions from data. Let's begin. Before we start, let's take a look at the course outline. The course is divided into three main sections. The first section, basic concepts of statistics, introduce statistical vocabularies, types of variables, data organization, and graphical representation. The second section, statistical indicators, focus on measures of central tendencies such as mean, median, and mode, as well as measures of distribution and data variability. The third section, statistical interpretation, covers units and curves, which help us understand the shape of statistical distribution. The structure takes us from the data collection and organization to analyzing and interpretation. Descriptive statistics provides a global view of a population based on collected data. This process begins with the raw data, which represent the initial observation collected from a population or sample. Next, the data is classified and organized to make it easier to analyze. It is then presented using tables and graphs to highlight patterns, trends, and relationships. After that, statistical measures are calculated to summarize the main characteristics of data. Finally, the results are interpreted to draw conclusions and support decision making. In short, descriptive statistics transforms raw data into meaningful transformation. Now, we begin with the basic concept of statistics, where all ideas are closely connected. The statistical study starts with the population, which is the entire set of individuals under investigation. Since studying the whole population is often not possible, we use a sample, which is a smaller group selected to represent it. Each element of the population is called a statistical unit or individual, and observations are made on these units. A statistical variable is a characteristic measured on each individual, such as age, height, etc. Finally, modalities are the possible value or categories that a variable can take. Variables are classified into two main types, qualitative and quantitative. For qualitative variables, describe categories and divided it into nominal variable which not ordered and ordinal variable which follow a logical order. Quantitative variables represent numerical values and are divided into discrete variables which are countable and continuous variables which can take any value within a range. Let's consider a simple example. A company studies 300 employees. This graph represents the population and each employee is an individual. The company collects data on department, salary, education level, and number of joining courses. Each variable has a type. Department is qualitative nominal, salary quantitative continuous, education level qualitative ordinal, and number of training courses is quantitative discrete. This helps us understand how variables are classified in a real situation. Statistical series is the set of observed value of a variable across all individuals in a population. From this, we define key concepts. Frequency is the number of times a value appears in the data set. Cumulative frequency is the reigning total of frequencies. Relative frequency represents the population of each value in the data set, and the cumulative relative frequency is the reigning total of relative frequencies. Now we move to the representation and tabulation of data. Consider a survey of 60 families recording the number of children per household. The raw data will be organized into a table to better understand its structure and distribution. This table shows the frequency, relative frequency, and cumulative frequency of each values. It provides a clear summary of data sets. We now move to graphical representation of data. Common tools include bar charts for comparing categories, P charts for showing proportion, and histogram for continuous data distribution. Cumulative frequency curves help analyze how data accumulates across values. These tools make data easier to interpret visually. Finally, we illustrate the previous table using bar charts. Each bar represents the number of families for each number of children. This allows a clear visual comparison of the distribution. This is the end of this introduction to descriptive statistics, and thank you for watching.